Hello everyone, welcome back. Today we're going to be looking at the final part of the binomial theorem, which is the last part of the first section in the Advanced Higher Maths course. Hope you caught that. As you can see in writing here, this is actually the binomial theorem. Now it might look a bit daunting at first, but I'll explain it good enough so that by the end of this lesson I will hope you will understand this. Right, let's get into it. So first what we're going to look at is Pascal's triangle again. Now I made a video on Pascal's triangle, which is just the video before, so if you haven't seen that yet, then I suggest you watch that and then come back to this. It will only take a few minutes. So I've already explained what Pascal's triangle is used for, and it's the coefficients, which just means the number in front of the special bracket x plus y to the power of whatever. Okay? And as we can see, as we go down here, the numbers get bigger and more complex in different series of orders, right? So this is a very useful tool in the binomial theorem, where we actually use the numbers here in the actual theorem, which is actually in this form here, in the binomial coefficient form. But just taking you back a bit, so if you look in the middle here, we have x plus y to the power of 0. The responding part on the right hand side is 1. If we have x plus y to the power of 1, corresponding right hand side is x plus y. And then x plus y squared equals x squared plus 2xy plus y squared. And then if we jump down to x plus y to the power of 4, we see now that it starts to get more complex. So it becomes x to the power of 4 plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the power of 4. So we can see that this would take ages to do if we were just to multiply out every single bracket. You'd spend half an hour on the question. So let's take a look at one specific example. X plus y to the power of 4. So as we can see here, that creates what I've just read out. Sorry. And what I've underlined here in green are all the coefficients, and we can see in Pascal's triangle on the left hand side that those match. And then let's now take a look at the powers. I didn't go into this in the last video, but this is the new part. So we have x to the power of 4 first. Then, as we can see along, x decreases in power every successive term, which is what I've written down here. So term x starts at x to the power of 4 and then decreases by 1 each successive term, right? And then term y does the opposite, where it increases every single term. Okay? So it starts from y to the power of 0. That's why I haven't written it in at the first part. And then it's gone all the way up to 4, where x is actually now x to the power of 0. And you can see in each part, sorry, I'm losing my voice a wee bit. As you can see in each section, so let's take 6x squared y squared, the powers of x and y always add up to the power of the bracket, okay? That's a very important rule. Let's go on to the next part now. So this is just Pascal's triangle with the terms of x and y in it, in the form of the binomial coefficient. Now this is actually what we use in the binomial theorem with the form of the binomial coefficients. And just a wee reminder, I've circled a random binomial coefficient where 3, 2 equals 3 factorial over 2 factorial times by 3 minus 2 factorial. Now I made a video on factorials and it's just in the previous series, so if you'd like to click on that, again it will only take a few minutes, but it will be a massive help, okay? And as we can see, doing all that work, we get 3. And then I've underlined it in orange here, so let's take a look back. And as you can see, in x plus y cubed, in this line here, right, this one, we have x squared plus 3x squared y plus 3xy squared. And that 3, the second 3, matches this one, okay? So they're just corresponding numbers, right? Next part. So I've written an expanded term for the binomial theorem. So this is actually, the top part is actually the binomial theorem. It's just not in its shortened version with the sigma notation, which I'll go into in a second, right? So let's take another example. X plus y to the power of 5. I apologise for my squashed writing here. So that equals 5, 0, and then we increase the bottom number of the binomial coefficient all the way up to 5, because 5 is the top number, and we go up to the top number. Okay? So, and then we have the terms of x and y, okay? And we follow the rule, x decreases by 1 every successive term, y increases every successive term, okay? And then after that, we get x to the power of 5, and so on, right? And this is a quicker way of expanding brackets by far, and as the brackets get more complicated, the binomial theorem will be your only choice to go by, okay? So, let's look at more complicated situations. So, 2x minus 3y cubed. Now, I've highlighted the negative sign here in green because this is something that I find just from experience. It's just something that you forget if you haven't done it in a few days, because you may think, oh, where does this negative go again? Do I put it to the front? Do I keep it still? So that's just a wee reminder there. Okay, keep the negative where it's supposed to be, and that's beside the coefficient it represents. Okay, and expanding the bracket cubed, we get 3, 0, 2x cubed, right? And let's take a look at 3, 1. So 3, 1 times by 2x squared times by negative 3y. Okay? So that actually makes that part of the answer negative. Okay? So remember that. The negative is very important. Okay? And then plus 3, 2, 2x times by negative 3y squared. Now, it's not negative this time, that part of the answer, because we're squaring a negative, which makes it positive. Okay, and just a wee reminder here that the negative 3y squared equals negative 3 squared times by, oh, that's not a times at all, times by y, what was it, times by y squared, yes. So there we go. And then negative 3 squared is 9. And then we expand it all out, and then we get the answer. So that's a more complicated situation. But you can also go a little bit more complicated. I'm not covering it in this video, but I'll cover it in a later video, where we actually expand trinomials. Oh, everything gets worse with trinomials. Now, for the final part, this is the binomial theorem, and all that's new here now is the sigma sign, which is just the big E at the start. It's a Greek letter, and that means sum, or to add up. Right, so you have plenty of videos explaining sigma notation. It's actually really simple. It's just the sum of a function, okay? So there we go. And if we expand that term, then we get n0 xn plus n1 xn minus 1 y 1, and then so on until you get up to, right, this is what it represents here. So going from r equals 0, r is here, all the way up until we reach n. Okay, until r equals n, we add up. Okay, so that's pretty much it for this video. A little bit shorter than usual, but we're just covering up. I have a few tips for you today. There's a brilliant site called Advanced Higher Maths Free. That is the place to go for your main revision. Okay, they have plenty of questions on every single topic, past papers, mock exams, stuff like that. That's what I use for my revision. I cannot stress it enough how much you should use this, because this is a dream. You wouldn't get this back 20 or so years. You'd have to buy books, but this is just a glowing opportunity. Okay, thank you very much for watching today. I hope you enjoyed and learned something. I enjoyed it with you. Alright, bye bye.